Thank you, Pam. This is pretty loud. You guys can hear me okay? Typically I have a quiet voice. Maybe I'll move it down a little bit. Is that better? All right. Maura Erasmus. I'm with Commscope. I run our global Smart City initiative. Now, you might wonder what a smart city got to do with smart base. We'll cover that in a minute. Quick little bit about Commscope. We are a connectivity layer 1 provider. So we actually make physical fiber, copper, Cat5, Cat6 cable every 2 weeks, enough to go around the earth. That's our production. We do it in 140 countries globally. We also own the Ruckus brand, wireless Wi-Fi, and then the Andrews legacy LTE, 4G, 5G network antennas for licensed spectrum. Looking at this picture, this is kind of how we play in our smart city space, where we typically start with the inside, the smart building. And then if you think of a building in a block radius, your campus, your community, that branch out a little bit, your shopping center, your stadiums, your hospitals, your schools, and then lastly into the city with your transportation network, your macro layer with your licensed and unlicensed wireless spectrum overlaying that. And that is very similar to what we see today in the post or the base 2. What I want to cover today with you just is a little bit, why do we believe this is a utility, connectivity, and why we should start treating it that way? What is the type of networks that's out there today? And then lastly, a couple of the trends in our space. Where are we seeing technology move from a macro perspective? And then also deployment considerations. What are some of the stuff you guys should be aware of as you're trying to build and plan your forward basis? So what's the similarities between a base and a city? This is a small city. I mean, this is what you guys build day in and day out, what you work with. There's no difference here. So very relevant to in our terms. Why do we believe this is a utility? If you look at penetration of the internet now these days and the actual facts surrounding this, I mean, there's a huge thing around urbanization. In the US, it's over 90% of the population live in highly dense areas now. So you really need dense coverage, which is different than just general coverage in your space. And it's interesting, the statistics, how many mobile devices is out there. It's only 50% penetration, but that's not 50%. A lot of people have 1, 2, 3 devices now. So we need to really start treating this. I like to take the analogy, when we build a house, any building plan in any city, you need to look at electricity, plumbing, your gas, your water, your sewage. And then maybe they throw a POTS line in for a phone. Well, when last have we run a telephone line into a house? But yet there's no AHJ throughout this whole country that's saying you have to put a fiber line into your house, because that's what people really need. So I think we're a little behind the times on a connectivity, and we should really start treating it as such for connectivity perspective. So how do we see the smart post? It's really about connecting edge devices, even in the smart city too. It's all about, what is this IoT device sitting at the edge? How do you connect it? How do you communicate it? And I believe that the HD camera, for example, is just one, is the IoT sensor of the future. The stuff we can do today with high definition cameras is unbelievable. We look at a couple of applications here that's deployed throughout the world now. Speed cameras. You guys are all familiar with parking. How do you find a parking spot somewhere? Toll parking, security control on vehicles entering and exiting your base. Emergency response. Do you send one ambulance? Do you send many? We know autonomous vehicles is coming. Don't even want to go into how that's going to affect us. There's vehicle-to-vehicle communication and vehicle-to-X. When we start flying drones around like cars, who's going to control that? It's not going to be an air traffic controller. It's got to be automatic. What's the network that's going to control that? Moving into maintenance optimization, you guys have all heard of now with big storms going through, all the carriers are flying drones now inspecting their towers. You can quickly inspect your assets. It's all about video analytics. And then lastly, this you guys are very familiar with, facial recognition and starting to process AI with the imaging. And that brings us into this middle section, which is even more exciting. We see a lot of play out in Europe now with violence detection. In Asia, somebody throws a punch, camera picks it up, send it out to the NOC. Emergency alert. Gunshot detection. If we think back this horrible incident at Fort Hood, what was it, 4 or 5 years ago? That if we had that technology available, you can pinpoint where the perpetrator is, quickly send emergency response there, isolate the areas, much faster response. And all this rides on connectivity. So to enable this, from the tallest towers in the world, we built the fiber, the copper. How do you get a cell signal on the 167th floor? It's challenging. But we've done those buildings to the Vietnam District 1, classic example of the areas where you don't have this great technology at play. But even cities like this is now starting to take their overhead, push it underground, much more resilient for hurricanes, for natural disasters. And as they deploy their power lines, they're adding connectivity now for that. So one way to start driving this influx of connectivity. And I think it's really about changing our mindset. If you look at these three companies, 10 years, 15 years, they didn't exist. Today, they're the behemoths in their industry. Uber, they don't own a single car. Well, now they start leasing stuff, but they don't have vehicles. Same with Airbnb, no inventory. And the only way this model works, and this is the model of the future, as a service, the only way this thing works is if you can track, monitor, and monetize these assets on a very quick way. So to get there, we need two things. We need wired and wireless connectivity. And a lot of people ask me the simple questions like, oh, but 5G is coming. We don't need fiber anymore. Like, you do realize there's no wireless without a wire somewhere. And there's this misconception, really, and we really need to be prepared for that in this space where I think wireline is very good for secure applications. It enables your wireless. That's very important. And then really focusing on static connections. And today, more and more, we're starting looking at hybrid cables. Have you all guys heard of hybrid fiber cables? Where we actually run fiber with copper conductors with it. Because any edge device you deploy today, you need power and you need connectivity. Now, it's great slapping batteries. Hey, we're going to have 20 billion IoT devices in the next 10 years, whatever. Well, what happens in 10 years from then? January 1st, 2030, when that 10 billion devices need to swap out their batteries. One, where are we going with all those batteries? Secondly, they're not going to happen January 1st. They're going to constantly fail. So if you can supply, say, for example, either fiber or copper, but you add copper to it, you power the device and you communicate with the device. Think of PoE devices. Much more resilient. Plug and play, you forget about it. So big uptick in that kind of market today. And then secondly is wireless. Everybody is on Tether today. I mean, it's amazing how this thing is taking over, and everything's about 5G, the mobile evolution. So they're very cost effective for IoT, quick deployments, quick asset management, and then secondly for nomadic connections. If you want to spring up a quick wireless network, great with Wi-Fi or with wireless applications. And there you got to look at your cell towers to enable this. You got to look at your small cells. And we'll go into this in a minute, what's the difference between the two and why you need both. And then lastly, your in-building wireless, your private networks. Has everybody heard of CBRS? And what's that bringing to us? We'll cover that here in a second too, but that's a big play in the US especially on private networks, which is probably very relevant to you guys on bases. And then Wi-Fi. I mean, that's a must in any postal base. And without proper planning, this is what you get. And in cities, this is a big problem. On the base, this is a big problem. So we definitely want to try and address some of these issues. So looking at some of the trends we see in our industry and what is coming down the pipeline in our connectivity space, PoE, convergence of networks, big topics today. We know the mobile revolution with 5G is coming. And then MEC computing, edge computing, taking processing power closer to the edge. And what's that applications we leverage? And concealment solutions. Big issue. How do you conceal all this IoT and edge equipment that we're going to put on the base there? and all to improve quality of life, drive up efficiency, and improve the quality of life for your folks on the base. Safety, security, supporting the forward mission. That's what we're really trying to do here. So I'm sure you're all familiar with PoE. It started in the 2000s, 10 watts, power the phone. Last year, the IEEE approved 90 watts. 90 watts. The new big screen OLED televisions, it's around about 35, 40 watts. So you can plug in a television now with a PoE cable, power and communicate on it. Don't need AC. And that's pretty much where this stuff is going to. And now what does that do for your power generation on your base, for your UPS backups on your base? So this is a big, big thing, for especially in buildings, where we now start seeing any smart building. I think really the Nest thermostat revolutionized that. My Nest thermostat is more technology advanced than the $500,000 air conditioning system controlling this building today. And as that process is continuing to evolve. Sorry, go ahead. No, not yet. Depending on what microcells, they're driving power down onto the 5G smaller stuff, but not they're still in the hundreds of watts. So, but for in-building, and we'll go here external applications next, but for in-building, if you think about your HVAC, your lighting, with LED lighting, they're pushing that. By putting that all on PoE, one, it's a DC distribution system, so it makes it simpler, safer to work in your building. But also you feed back all the data from those devices on the same cable. So it's not multiple overlay systems.
I'm just thinking of the 5G overlays, you get power to spin up the power of a microcell, and you get some.
Yeah, I think there might be some different, if from an in-building perspective or from an external perspective. On in-building, there's some really interesting stuff coming up. We're trying to figure out how do you incorporate your wireless network, say, for example, in your LED lights. Can you leverage that same platform or not? You need, inside the building, you need both licensed and unlicensed spectrum. So how do you cover both of those and not run, and we'll talk a little bit about convergence here next, where we're starting to see more and more of these networks. Because today, if you dig out here in the street, you can hit any one of 7 or 8 different fiber networks, all running ones and zeros. And a lot of time it's the same company that's running the fiber. So how do we converge some of these networks? And from a security perspective, this is very important in your buildings, because what's happening today, by bringing all your building automation systems on an Ethernet layer, you can better secure that. Because what's happening today, I was in Australia recently, and a large developer told me, he's like, well, we don't want any of that stuff touching our IT. And then the consultant said, but sir, you do realize we have 17 DSL lines coming into our building, running all separate control systems. Well, why don't we put it on one? We know you don't have to put it on your corporate network or your secure network, but duplicate that network. Let's not reinvent the wheel. You have safety protocols. You know how to secure those networks. Put your OT system on there, and then put your corporate or your secured network separately, but duplicate it. And that we're starting to see more. Because we've done some incredible stuff with that. For example, like lighting applications. You put a light on, you turn it on when somebody's here or not. Well, what if I link it to my HVAC? Nobody's here in the building for 30 minutes, start dropping the temperature a little bit. When I know there's connected to my Outlook calendar, when somebody's coming in, they can start cooling the building again. So by being smarter in that, you can start saving your resources a lot on that. And that, of course, power consumption, generator consumption, fuel consumption, it just drives efficiently all down the chain. So outside or inside the building, that's one. Next is, what do we do outside? You've all seen these things on the poles. You've all seen the AP sitting out there, security cameras. To enable that, you need power. And in a lot of cases, when it's secure applications, you need backup power. Now, you guys are more familiar than me. Some of these places you go to, how long is a battery going to last out in the desert sun of 100 and how much? So how can you help and provide that at a better environment? And that's really where this powered fiber I talked with earlier today about. You have your fiber in the middle, copper on the outside. And with solutions like this, we're running now up to 3 kilometers, which is what? It's almost 2 miles. PoE that's typically only 300 feet, run now 2 miles distances so that you can deploy your security cameras outside in the parking lot at the edge of your perimeter. You can pull your Wi-Fi where you need it. You bring it all back to a central location. You back it up with genset or with batteries, and from there you deploy it out. Now, here we show some of this. I think we had, small cells. That would be one of the applications where we want to go with this technology. As the power is coming down, now there's an interesting trend with massive MIMO antennas. The power is actually going up. It started to come down, and now it's jumping up again on these big arrays. But I think with small cells, we're still going to try and force that lower deployment. On converging of networks, this is a big thing that's been driven by the carriers, AT&T, Verizon, Deutsche Telekom, these guys. And what they're doing is, traditionally they would run a fiber line to your house, fiber to the home. 2 weeks later, they come again, dig up the same street, put another fiber line to a cell tower. We're like, but you're the same company. It's all ones and zeros. Why can't you converge this? And now they're starting to look at how do we build this out to converge networks. Don't have to be on the same fiber. Not yet. Let's physically separate it, but run it in the same conduit. Run it on the same pairs or conductors. How do you start converging this message and really build out to be more flexible? So when you want to add smart poles, traffic control, security on your base, kiosks, you guys probably don't care about that too much, but schools, hospitals, all these different entities, everybody needs connectivity. How do we build this to be hardened, plug and play, big thing. You don't want to have people coming out constantly and splicing fiber, especially not in those conditions. So make it plug and playable. This is a very interesting application too. So we got all these IoT unsecured edge devices that's out there. Don't want to put that on a secure network. So leverage some of the other networks you have. For example, what if you have a Wi-Fi network, public Wi-Fi throughout your base? That's not a super secure network, it's public Wi-Fi. Well, by plugging in some dongles, you can now pick up other protocols. We translate that, and then you send that information up in the cloud. So that gives you a way to share basically your connectivity layer between different platforms. You have your public Wi-Fi that drives also your IoT layer, and it doesn't influence your secure layer. So how can you share these infrastructures? Another one that's very interesting is this piece about, on the physical layer, automated infrastructure management. Have you guys heard of that? So there's some new standards out talking about AIM. And what Commscope got with this product, basically, trying to explain to you, you have your, I can do it from here, you basically have your device or your switch where you want to run out to an endpoint. And we basically monitor every point along the way. We digitally map that. So you can send to a technician, hey, here's a work order. Go put this in place, connect these devices. Here's the port, here's the racks. Where do you connect this from a physical layer? And then on the panels, it will light up where these things are connected. It verifies that it is connected. So one, you have a record on where things are physically connected. And now if somebody goes and they unplug it and plug something in, you get an alarm, you get SMS messages on your phone or wherever you set it up, and it tells you from a physical perspective what was changed. One, it gives you solid records of where stuff is, and especially now that we talked about PoE. How much PoE budget do you have? What is connected on devices? So great record keeping. It helps with uptime. If that thing goes down, somebody accidentally unplugs something, you know exactly where to go and quickly bring it back up to speed.
And the ability to integrate on other platforms. So if someone is in an unauthorized space and they plug or they unplug something, you can actually, integrate a, a security camera with automatically capture an image.
Yep.
Of who that is. The tool also would capture MAC addresses of any device that you plugged into it, right? And so there's added layers of incident management. It creates a trail of revenue on this also to trace exactly what went on.
Absolutely. We have a large financial institution in the UK that's using this for people that unauthorized access at the desk level. Somebody came in and plugged into an outlet. How do I track that? How can I quickly map it? We also see convergence on the private networks a lot. We talked a little bit about CBRS, Citizen Broadband Radio Spectrum, which is I think it's the naval ships are using. But when they're not in port or not around the coast, then that spectrum band is unused. So they came up with the idea, well, how can we repurpose that spectrum and share it amongst others? So for that, you need some software that monitor when it's in use or not. And when not in use, they hand it down to a 2-layer tier priority access, which you can pay for licenses eventually, and then everybody else can get on this network. So what does this mean for you? It's essentially, you can now stand up a LTE or a private, very secure private network with minimal devices that you can now, for example, say a shipping port. You want to track every single container throughout the port. Today, you have to put in a chip, a cell card in every one of those containers. Very expensive. You need carriers to put it up there. With this technology, you can stand up your own private network and deploy that technology very inexpensively. And that's coming to a city close to you or a port close to you soon. So we can help you with those kind of solutions too. Then looking at 5G, you all have heard of 5G, what it is and all the promises. Well, really there's these 3 things that 5G stands on, the pillars. One is it's going to be very, very fast speed, 10 times what we're used to now. That's what they claim. Let's hope we get to 7. Secondly, billions of devices. The internet was never designed for machine-to-machine communication. That was not how it was set up from day one. This is a network specifically with network slicing, that applications that don't require high latency or low latency applications will be shifted around to those specific sector bands so that we can make it more efficient across the whole spectrum. And then lastly, this ultra-low latency. This is really what the holy grail is, what 5G is going to bring us. And why do we need ultra-low latency? Do we really care how quickly we download the Netflix movie? If it's 5 minutes or 10 seconds? Not really. But it's really about, I think this explains it well, the data centers is shifting and where MEC computing comes in. We started seeing, we play in the enterprise space very much, the hyperscales. You got now the multi-tenant where we share resources. And then lastly, this edge computer. How close to the customer can we get or to the actual application for latency? Why is that important? I think this is a great example. Today, if you drive, say, I live in Dallas, Texas. If I drive in my car and I do a Facebook message, I basically have to go to the West Coast or the East Coast. And then that message comes back to me on my phone. That's how it's get deployed today. So if I drive in a car, imagine self-driving cars, that's about 4 feet by the time it goes back and come back to me. If I put that data center essentially right next to the cell tower, I've driven 4 inches. Now imagine what kind of applications you can enable with that. And again, it's interesting because we talk about this and it's really hard to understand, well, what am I really going to do with this? And I think this is one of those things that we have to believe in. 10 years ago, none of us thought we needed an Uber. It didn't exist. Why would I ever want to need this? This is stuff that's going to enable that. And I think especially as we start looking at self-driving vehicles, drones, control, those things that virtual reality, augmented reality, those really low latency applications, this is where they come into play. And there'll be lots of billionaire 15, 20-year-old kids on this low latency applications that's coming in apps. So how's your base going to look different? What is 5G? How does it change the landscape? If you look at these macro towers, the big cell towers, typically these things in a high dense area, city of Chicago, covers 10 square miles, one of these towers. So very far distances, 4G, LTE, 3G, all these kind of big macro, it's about coverage. How far can I reach people? Well, with 5G millimeter wave, the technology, the high millimeter wave spectrum, only travels 300 or 400 yards. Not miles anymore. That means the only place to put these things is on street lights, because every third or fourth street light needs to have one. Because the millimeter wave doesn't penetrate as well. It gives you a lot of bandwidth. It gives you a lot of speed. Great with low latency, but it can't travel that far on millimeter wave. And that's why we're going to need a much denser. So this will be for coverage, how to cover vast areas, and this would be for density. If you have a high concentration of deployment around stadiums, around, I would think the PEMEX or the training grounds, even if you go out the building here, heading, I think it's north, there's a small cell on the corner where the AT&T FirstNet bus is. Right across the street, there's one of these guys standing. And it's really for that high density coverage that they need to put these on. And where will we put them? Where are you going to put them today? It's really about this Trojan horse here. We started with the lampposts, then we went into, hey, put some IoT stuff on there, small cells, and we're trying to get to this really cool, futuristic smart pole, but without proper planning, this is what you're going to get, minus the crow. Because we just keep adding stuff on it. How secure is this? How resilient is this? On the next storm, all that stuff's going to be knocked off the pole. So how do you prevent that? And why the smart pole? This is real. This is what we're seeing today. You see all these small cells now in downtown areas because we need that coverage. Everybody's got a phone, some people too. I'm amazed at how many people I see today that carry 2 cell phones. I'm like, one private and one for work. I'm like, but why? I mean, they even got phones out now that you can put 2 SIM cards in. I mean, it's just crazy. So that's why this is happening. Next one is IoT devices on there. Excuse me. Putting more and more cameras, putting gunshot, environmental sensors, noise control. And then 5G, we just talked about millimeter wave not traveling. I took this picture a couple of weeks ago in Vancouver, Vancouver, British Columbia. You walk out the airport, this is what their parking lot looked like. And this is not 5G even. This is on their 4G network. Because you have multiple carriers too. And typically they don't want to share. So each one wants their own pole. So we got to come up with a smarter way of doing this. And that's really where this comes in. How do we build a pole that is, hey, let's put an antenna at the top, make it 5G ready, leave it modular for IoT and devices on there. How do we put in the bottom power, fiber, radio modules, expansion? How do you build this so that it's modular and scalable for the future? And here's one we deployed in Dallas, the round one. We actually got just a section here, the top 10-foot section down in our booth. If you guys want to stop by, I think it's 351.
530.
Sorry? 530. Sorry, a little dyslexic there. And then this one is a pole up in Boston. Just a different footprint, square footprint, where we can put the devices in. There you got your antenna at the top, and then you can start adding your IoT devices. And the way to do this is, we really want to get to this thing. How do you enable this to make it more and more that you can quickly scale and deploy further? EV charging, digital signage on these things, IoT gateway. You want to run edge analytics on there. Maybe security, safety. You want to track somebody with their phone, where they are in the perimeter inside your facility. You want to run some edge analytics on there. You're going to need computers in there. And it all starts, today in our industry, we see 2 types of applications. One is what they call a IoT pole, the smart pole IoT stuff. And then the other side is this telco pole, this smart pole, or how do I get cell signal on the pole? And most people design from the IoT side, because that's the cool, sexy stuff they want to talk about, but not taking into account the connectivity required to enable that. So we really need to want to change the mindset of that. So first of all, with this pole, you got to start in the bottom with fiber to this. And that's just a given. Next is, okay, we got to put radios in for your 4G LTE. You need antenna, you need an RF path to that thing. And then 5G is coming, so be ready for that, prepare for that. It's not out yet today, commercially available, but it's coming, so prepare for that. Next is your public Wi-Fi. That's a must in every base now. And then you get to your private network. You're going to have some kind of private network on these systems in your bases. How do you deploy that? So think of that. And then lastly, if you don't have fiber, middle of the desert somewhere, microwave backlinks to get your signal out. So that is all the connectivity perspective that you need on this device. And then the cool stuff people want to talk about, there's the lights, there's the cameras I can put on there, run some AI with the parking apps. Those are all the overlay system for us. And then what about your environmental sensors, noise, radiation control, all kinds of different sensors they're putting out there now. And then digital signage potentially. If you want to, as people come in a base, you can have a digital signage that displays welcome or gives some information, who's today at the base or some important information. And lastly, your software platform overlaying this. But none of this happened without connectivity on the other side. So when you start looking at these assets, think of both sides of the fence. So in conclusion, it's really about how do you build this with concealment in mind, that's flexible, that's scalable, that's resilient. How do you make it plug and play? We have these hardened connectors, flexible connectors that you can put underground or in a pole. In fiber-poor networks where you don't have enough fiber, there's solutions there to WDM where you can actually add capacity through active and passive switching in there. And then enabling your smart poles. Those are kind of the three pieces you want to look at. And from a wireline perspective, think hybrid cable. If you guys are interested in that powered fiber cable, great solution. We see a lot of traction with that these days. On the wireless side, 4G today, 5G tomorrow. And you need both licensed and unlicensed. That's just a given. People need bars. People want the life, quality of life for your family on a base without, imagine your family without Wi-Fi in the house. I don't know who's got kids in this place. But just imagine what your household will look like without Wi-Fi signal. So they can watch their cartoons or their YouTube or their Netflix. And then concealment solutions, not just from an aesthetic perspective, but also from a resilient perspective. How do you protect this against the elements? It starts all with the smart building. Your data centers is the brain of this whole operation, so protect that. And that's kind of it in a nutshell. Any question?
Let's go for an hour for
Oh.
credit, so let's definitely come with the questions, and I definitely want to talk security.
Sure. No, I wanted to leave some space.
The big question I've got is security. How are they going to secure this? You get concealment, you get everything else, but when you put these poles up on a base, what's going to prevent somebody from coming along and getting into the...
Yeah, so on the actual base poles, that's a good question. Let me go back to that picture. Here you can see these little areas. It's a modular system. I think I have it on the previous slide, maybe. Whoops, let me go back here. Here we go. So there's modular sections in these poles. So you have your power coming in, and typically, you guys don't care about this because you supply your own power, but in the cities, each city has their own meters. So that section is lockable that only the power company can get into. So nobody else have access to that. This section up here where the radios go in is locked, for example, by AT&T. We put another modular section like that in, only Sprint can get in there, or a Verizon. So these sections is physically secured on each of these devices so that there's no unauthorized access in there. The same with this. You physically lock the doors where these devices come in.
And there's the ability to customize based on
Sure.
what the needs would be.
Absolutely.
So, the beauty of this is, we decided that we were going to deploy this at a location. We would want to be in consultation with the customer, say, hey, what compartments do you need? How many individually lockable compartments are you making on this thing? We'll go design it and build it out for you. So, I mean, it can be customized.
Sure. Yeah, no. Sorry, there was a question.
concerned but intrigued by the convergent fiber with electricity. I like having my fiber separate from electricity due to lightning surges. Are you seeing this deployed successfully and grounded well enough to survive the adversity of a lightning strike and have your ports withstand that charge that comes through this converged link?
So far, we haven't had any issues with this, and we've deployed this in South Asia, where lightning strike is a daily occurrence. So there's obviously, so if you talk specifically about the powered fiber or in general.
Once you've got something elevated that's got some copper running within the same sleeve as that fiber,
Okay.
find that hole.
Sure. That's an interesting concept. We actually starting to see a lot more the opposite happening. I mean, today in the code, there's definitely separation between low voltage or communications and power. Got to be separated, period. Because we're deploying more and more fiber today, people are saying, well, it's not low voltage copper, so there's not the only concern that they currently have deploying them together, I've seen, is around the safety aspect. You're getting now fiber techs getting into an electrical vault. Are they trained to operate in that space? That's the biggest concern I've seen so far. But from a lighting perspective, I've yet to see any or hear of any major issues on that, because typically those are isolated on their points and protections put in place.
Should I wish to power the backup battery that I recharge, you have a module in your smart pole to allow for a redundant power supply?
Yes, so you can bring in multiple power feeds into your pole. The intention today is not to install the batteries inside this pole. That is, technically you could, but from an environmental perspective, I think inside of these type of poles go up to 180 degrees or something. Any metal pole, in that matter, in certain areas. So the environmental constraints is very high inside these poles. So the idea with that powered fiber piece is, if you can remove that, say for example, we see at an intersection, a lot of times on intersection there's large cabinets for the intersection lights. There's already batteries there. There's proper cooling in there. If you put that powered fiber solution in that application and then just run down the street to each pole, the power and the hybrid cable to deploy then on each of these other. And you kind of come up with a master-slave configuration, running out 4 sections out into the street. That's how we've seen this mostly deployed in that application. The other one is applications, for example, in Dubai, the airport in Dubai. From floor to ceiling is more than 100 meters. So if you put an AP or a camera up in the ceiling, you can't even reach the ground, never mind then an IDF somewhere. What do you do there? You run into problems. So that's where these applications is very, very useful.
We talked a little bit about survivability before everybody came in, and you talked about one pole that would stand 175 mile an hour winds.
Yes.
So I've got a question. Talk about that a little bit, and also the other concern I've got is with the water table as low as it is in Florida. One of the things that I've heard that the people in Florida were looking for is some sort of survivable communication system. Is this going to work with a low water table, even the underground and some of that kind of stuff?
Correct. So from a flooding perspective, electricity and water don't mix. So there's just nothing that's going to save this from that perspective on the electricity side. So you'll probably knock out your poles, period. On these other devices, we have a patent technology on these guys. The way these things are sealed, we have a gel sealed patent technology that we're actually licensing to other vendors too in other applications. That it's a multiple sealable gel around the cables that allow for multiple. You can submerge those those devices. For example, you've all seen these big cabinets sitting on the side of the road where they splice all fiber in. That is the same thing as this, but you can put it in a tube underground. You can hang it against a pole. You can sling it from a cable above. Much more robust and hardened connectivity, essentially, for those type of applications, where you can, from a flooding perspective, be more resilient. On wind loading, these poles are typically designed to withstand whatever the forces is in that area. Like we talked earlier, Miami has probably got the highest wind load in the state here. I think it's about 175 miles an hour wind. Now, that limits what you can put on at the top. There's an RFP out right now for their city that in Dade County that they want to put solar panels to run solar lighting there. And on my mind is like, that would never work. You're putting up a kite up on a pole. Nothing's going to stop that thing going off.
So Miami, if I take and I'm considering deploying new at sea level on the coast, if I replace my pedestals with this device before I left, the next time I flood from a hurricane, this will withstand its IP rating so that it can withstand 8-9 days of submerged.
These units, yes. Those units are rated, highly IP rated. And we can go through you with the right specs that we specified, the correct ones. But on the actual pole, yeah, that's a problem people would have to fix. Now, we do have other solutions too. For example, I'll take you back to this one. This unit is actually a new pole, fiberglass pole, or what is it, a hybrid concrete pole, what they basically use here. But we have a solution that this box in the bottom, we make out of about 2-inch thick steel. So you take your old existing pole, and it's really in historical districts where they love the looks and feels of their existing poles. They take the old pole off, put this box in there, and then put the old pole on top of it and mount it on there. So that might be an alternative solution to those type of applications too. Any other questions? We got another hour and a half to go.
At least 15 minutes. From Kentucky's standpoint, from the air guard, what are your concerns? Does this answer some of the thoughts you're thinking about?
Not really. I don't think we're going to wait for the price point. We can be able to just across the rotation.
And is it a price concern? So when you say you're taking poles out, is that like power poles you're taking out? Power poles. We don't have overhead lighting. Really very little overhead lighting on those anyway. Interesting.
So, with the limitation on 5G and the limitation on distance.
Correct.
We'll have poles out there to cover that.
So you'll have to install new poles to cover your 5G applications.
Right.
And I think that's, so maybe, yeah, like I said, and that's not an imminent need right now, but as you start planning for that, how do you, if you put it underground now, that's what we did in Vietnam too. As you put it underground, think of where do I need expansion nodes that I will need in 2 or 5 years from now. That I think is the biggest point we want to bring across, that build your network so you can quickly expand upon it and not redig and resplice everything.
And we put conduit all over the bases.
Great.
And
then how do you guys treat your power and fiber? Separate, communication separate from today? Good, good. So that's very important to build that resiliency in. Anybody else? Different base. If you don't ask questions, we're going to ask you.
Can you go back to CBRS?
Yeah.
And just touch on a couple of potential use cases?
Yeah, I think it's still in the evolving process right now. So we have basically 2 types of CBRSs. One is really for indoor. Let me pull that up. Here we go. So one is for indoor category A, which is low power CBRS. And then category B, which is still in development, is basically for the outdoor. How do you get more coverage with this? And the whole concept there is it look like Wi-Fi and a Wi-Fi deployment, but it's on licensed spectrum. And the advantage is it travels a lot further. It's much more secure, that's what they claim, than traditional Wi-Fi because it's based on this LTE technology.
I think that one of the key plays for this also is if you take a look at you've got multiple locations, or even just take a look at the Air Force, for instance, overall, where they put out a large RFP to all the carriers saying, hey, we want to deploy 4G LTE to all the bases so that regardless of where you are, you're going to have the same level of connectivity. And carriers get really excited about providing infrastructure at Andrews Air Force Base. But some small remote base, they're not going to want to really deploy the capital to build the infrastructure there. So this is an option to provide you, if you have multiple locations, to have a common platform that is enterprise-owned. It's your own private network, and you can have the same level of service that you need, and also be able to manage, who has access to that spectrum, who has access really to that network. And so that's the unique thing here. This is when you run into a problem where the carriers more and more, the trend is that they are letting the owners own the infrastructure there. And this is just yet another way. And then we can provide ways when you can, in the building, get connected to the carriers as well.
Yes, and provide that offloading from the cellular system. So if you have a space on the base where you don't have a good signal, AT&T is not excited to come out to sign up 20 customers. They're not going to put a new pole up for you. This is your solution. Or this is what we envision will be the solution when this come out. And today this is only being considered in the U.S. because it's our spectrum and that's kind of a U.S.-centric piece. But the rest of the world is looking very closely as how this model will work. How can you repurpose spectrum? Because spectrum is an infinite amount. You can't just keep adding that. So that is one application. The security aspect of this is a big piece. It's a big attraction to this. What was some of the other use cases? There's a whole host. The CBRS Alliance is building. Emergency response might be one where they could get better coverage in building for it.
So it provides a room offloading certain types of traffic within the facility. So if you take like a medical facility, you've got an existing Wi-Fi network. You're providing Wi-Fi that's utilized both by patients, doctors, guests, medical devices, medical equipment. There's an aspect that some of that equipment may need a more reliable, secure, always-on network that you don't necessarily get from a traditional Wi-Fi network. So this provides you the ability to build an LTE-like service that you control, that you own. Devices are only connecting to the network that you authorize because, again, it's LTE-based, so it's, you've got to register a SIM card. So if I don't register that crash card in the OR, then it's not getting on the network. But at the same time, if I need that crash card at the end of the facility, and the Wi-Fi signal isn't as strong there, or it's congested because, again, Wi-Fi shared spectrum, I've now created this internal LTE network. It doesn't go anywhere. I'm not connecting it to a carrier network, but I've provided LTE type service and security within the facility. Another great example that I like to tell people about is in a skip. You can't take cell phone in a skip right now. But how many people are in a skip moving around the facility that you might need to get hold of? Wouldn't it be nice to go when they come in, you lock your phone up in the locker and you hand them a phone and here's your in-building cellular device that I can call you now. I have LTE service, I've got voice service, and I can reach you anywhere in the facility. And then when you walk out at the end of the day, you take it out of the skip, well, it doesn't work on a traditional network. It's locked into the facility. Or I take it back from you, lock it up, and now take your other phone out of your locker.
And then couple that application with the GPS tracking capability. You know where people are. You know in an emergency where to find them. If there's a perpetrator you want to quickly find or locate. I think there's a lot of these applications. And we're starting seeing more and more of these apps being native to a mobile platform now. You walk in a building, you can control your lights. You can control your environment or door access key cards is all going to be driven by this. And I think that's where this really private networks is going to make a huge impact from a adaptable standpoint, because putting it out on a public Wi-Fi network, it's challenging. Although we're doing a lot of work with, for example, the Ruckus guys are doing a lot of work with Hyatt. Is it Hyatt or Hilton? Marriott. Where you can open your door keys, you can turn on your TV, you can pay for stuff, you can control stuff through there, all on the IoT platform running on the wireless piece and not impacting your corporate or your secure networks. So I think that's where this will help a lot to get even more security and a faster adoption to that.
We deployed at Phoenix Raceway and one in Texas. They built it as an overlay. When I described the medical facilities, they built it as an overlay for vendors, because the vendors themselves, when I was selling beer at the racetrack, they couldn't reliably get their little point of sale devices on the Wi-Fi network because there were too many people Facebook in the race. So they built an overlay network using CBRS. And again, it's private. They own it. They bought the gear. It deploys just like Wi-Fi, provided an overlay network for them to bring their point of sale devices behind.
Absolutely. Any other questions around?
Got time for one or two more, and then we meet our time.
Okay.
So we do need one or two more questions.
Pardon?
Do you envision any tactical use?
Tactical use.
Yes, actually, very much so. So because of the ease of deployment, right? So you know Bob, and I can now throw up a private LTE network that I own, I control, I have access, and
If
it,
you're denied territory, you own it, you own the spectrum anyway, so it's your spectrum now. And again, full command post, Bob, private LTE network that is not based upon any carrier, you are the carrier. And that is the beauty of this. Think of a building like the Pentagon. You've got massive, it's terrible for Wi-Fi. You've got all these distributed antenna systems, all the carriers running there. Take a cell phone in, it's over the carrier network inside the Pentagon or anywhere else. Now, you have the ability to basically run it all as your data, your device, your network. And if you choose at a certain point to do a handoff of voice to the carrier, you go outside, that's your choice. Otherwise, you run it all inside yourself. So yeah, absolutely. Tactical applications. We've got guys like ATF, FEMA, DEA. You go down to Tyndall Air Force Base and there's nothing down there. Now you can stand up an LTE network. Korea goes down and then all the carriers are gone, and literally gone.
Well,
The ability to stand this up.
the Guard usually get deployed into, when a hurricane takes out all Puerto Rico, right? And there's no existing infrastructure there. But your guys need to communicate, so the ability to come in and prop up that private network really quickly. And it's your spectrum, right? You're the only one that's allowed on it. That's pretty valuable.
And I think the beauty about this is it deploys like Wi-Fi. It deploys on the Wi-Fi backhaul system. So you can literally run a CAT cable, put a Wi-Fi access point in, and then with the Ruckus gear, I would recommend you come and look at it. You can actually plug in the CBRS module right next to it and run on the same backhaul.
Yeah, the limitations thus far recently is the devices haven't necessarily don't have CBRS radios in them. The new iPhones, the iPhones in Japan have them. Samsung Galaxy tablets, a lot of the new Dell laptops are all going to come with CBRS radios inside the laptops. So the devices are starting to catch up, and when the devices catch up, then you have the ability to build these networks.
more mentioned, it's primarily code-based technologies because 3.5 gigahertz spectrum is used overseas. Europe uses it as, for their LTE network. But again, we're seeing a lot of interest from, other outside of CONUS or OCONUS entities, countries that are looking at it. Well, we have a slice of spectrum that's not used. Maybe we could do something similar.
No, absolutely. This is because Commscope actually that software that controls is the band in use or not, and then who can be allowed to use the band. That software Commscope make those software too.
Yeah,
us, Google, federate the SAS.
Make it tactical, is to make it private SAS. So again, military controls the spectrum. You have a private SAS for yourselves. You control which military units get to use the spectrum. So that's the next evolution.
All right. Any more questions? If not, thank you very much for coming.